All right, this is Matthew Matt, and I'm here to talk to you a little bit about the Common Core Standards for Mathematics, and in particular what they say the big ideas are in third grade. So they talk about four critical areas for third grade mathematics. The first one is multiplication division. The second is area. They talk about introductory fraction concepts, and finally thinking about shapes. This video is about area. And I've already said a lot of what I want to say about area, but I want to talk about it a little more. So what is area? A lot of you probably learned a bunch of formulas in school like 1/2 base times height, or pi r squared, or some of these other formulas for different shapes. But all of those are really just ways to figure out how many square units will fill up that shape or that flat space. That's what area is fundamentally about, is saying how many of our little squares, whether they happen to be square feet or square inches or square centimeters, how many of them are going to fit into this space. And especially, we might have to cut off some some partial pieces or things like that. And how do we account for that? Fortunately, in third grade, kids don't have to worry about all those shapes yet. They're really just focused on area of rectangles. And I just showed this, but I really consider it an important idea, so I want to show it one more time, which is that when I'm looking at a rectangle and I'm measuring one direction, I'm measuring how many rows there are, and in the other direction, I'm measuring how many squares per row. And of course, I could flip it and I could do columns and squares per column if I wanted. But the big idea is that that's one way to think about what these measurements tell us, and why we are then measuring in square units instead of, so why we measure, say, square inches or square feet instead of inches and feet. Right, there's other things that we might want to think about when it comes to area and mathematics. So for instance, if I'm doing a problem like 4 times 12, I can visualize it like this. And I could do 12 4 times, or I could do 4 12 times, but those aren't the friendliest numbers for me. So I might also choose to break the problem up and look at it like this, which I can think of as 4 times 10, which I know is 40 because 10s are nice to work with in our number system. And I can think of it as 4 times 2, which I know is 8. And then I can solve the problem a little easier. And these are the kinds of things kids should be working with and reasoning about when they're solving a variety of problems.